Locus. A locus is the set of all points in a plane that satisfy a given condition or a set of given conditions. So it could be more than one condition. If you ever talk about the plural of locus, it's called loci. Said like that. Kind of like hippopotamus, hippopotami. Same kind of plural. Radius, radii. Now, draw a line K. So we're going to find some locuses in this section. And when you're looking to find a locus, first, if they say draw a line on a piece of paper, you just draw a line. Your line can be anywhere. A lot of people would like to do it parallel, but I'm just going to slant my line a little bit. Since it's a line, it keeps on going. It's not a line segment. The next thing it says is draw and describe the locus. The locus is the set of points, set of all the points that satisfy a given condition. So what are the points that satisfy the condition that the points are 1 inch from this line? So I put a ruler on here. I'm actually going to make it smaller. Just wanted it for my scale to show you what an inch is. Make my ruler a little bit smaller. So I want to describe all the points that are 1 inch from this line. That's an inch. This is approximately an inch. So these points are all an inch from the line. Realize points up here could be an inch from the line. So I'm going to plot enough points so that I can make a general statement that all these points, if I drew every single possible point in, would be this line. Okay, all the points make a line when we can put them all together. Okay, a line is made up of a bunch of little tiny points. Okay, so then draw and describe. So I'd say, 2 lines parallel to original line, 1 inch from original. Something like that. I mean, I'm not the best describer, but it's important to describe them. A lot of people get confused, like, what the heck is this locus thing all about? One of the reasons we talked about this and in this section is the definition of a circle is described by a locus. Okay? It's described by the locus of points that are all the same distance locus of points that are all the same distance from a point. So for example, a circle, here's a point, all the points that are the same distance away. If I start drawing some of these points that are all the same distance away, what do we start getting? We start getting this circle. That's what a circle is. We use locus to describe that. So, some steps for finding a locus. Draw a picture. Locate enough of the points to recognize a pattern. And then show that pattern. Draw in the pattern with a line or a circle or whatever it's going to be. It might be a point. And then describe it in words. Okay, so step 1. Read through it. What is the locus of points in the plane equidistant from AB and segment AC? So first, I'm given AB and AC. So I'm going to start by drawing line segment AB and line segment AC. So notice I have to have a C in there. And also, so here's the second equidistant from here and equidistant from those 2 points. Well, So now I'm going to start locating some points that satisfy the first condition. So this is the first condition, equidistant from AB. So notice this point is not going to be the same distance away from those two segments. Where they're going to be the same is along this kind of dotted line. This point is going to be the same distance away, that point, and so on, to probably a certain extent where, since B ends here, we probably can't go past a right angle. So we probably have to stop right there. Now the second condition is, and also equidistance from A and B. So they have to be the same distance away from A as B. So if we look at this point is not the same distance away. Where is it going to be the same? Somewhere about there. I'm going to say that this length and that length are the same. This is the one point that satisfies both conditions. This is my locus in blue. The green was the first condition. Maybe I'll draw this out. All these points in blue are the same distance away from B as in A. Actually, that's not even true. Let me undo that. All these points are the same distance away. This point is the same distance away from A as B. So where here is my locus, and that one point satisfies both conditions. Okay, so describe that now. We found it, draw the locus, did it in black here, and then describe it in words. It's just going to be a point on an angle bisector of angle BAC. That is also on the perpendicular bisector of segment AB. So this is a perpendicular bisector, that's an angle bisector, and that's how I'm describing the locus. So the next example, what is the locus of points 2 centimeters from X and 3 centimeters from point Y? So point X, point Y, that's the first step. Draw the givens. Locus of points 2 centimeters away from X. Okay, so this is 2 centimeters. And this is 3 centimeters. What are the locus of points that are both 2 centimeters and 3 centimeters? Okay, this is 2 centimeters away. This is 3 centimeters away. Also, this point is also 2 centimeters away and 3 centimeters away. So it's going to be 2 points. That are the same distance, that are 2 centimeters from X and 3 centimeters from Y. Now this is where it kind of gets interesting, and you can actually find the epicenter of an earthquake. And now, so in this problem, it's not drawn to scale. I kind of just overlapped a grid on top of California here. And we're going to use loci to find the epicenter of an earthquake. And we're going to pretend that one of these units is a mile. Okay, so first I'm going to plot the point and draw in all that I know. So -5. 2, 3, 4, 5, 5, 1, 2, 3, 4, 5. This point right here. So there's some station here, and it registered an earthquake 4 miles away. So it could be in any of these directions. Now, drawing in a circle here. the earthquake was somewhere out on this red circle. Now, doing the same thing from -4, 3.5, -4, 3.5. This center registered the earthquake at 5 miles away. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 this way, 3, 4, 5. 1, 2, 3, 4, 5. So this one registered the earthquake 5 miles away. So a second station, terrible circle, but notice these are kind of the key points where the two stations picked up the earthquake. It's going to be either one of these 2 points. So now with a third station at 1.5, actually 1.5 is over here, and I hope I did this right, 7 miles away, 1, 2, 3, 4, 5, 6, 7. I think it might have been supposed to be back here. I did it here. 1, 2, 3, 4, 5, 6, 7. I think it was supposed to be here. Let's change this to a -1. Up 7. 1, 2, 3, 4, 5, 6, 7. Okay. 2, 4, 6, 7 would be here. So you get this one registered the earthquake somewhere along here. But notice this is the one place that satisfies all 3 conditions. Okay, so this is where the earthquake happened. It's 7 miles from this center. We call this a -1. It's 4 miles away from the red center, and it's 5 miles away from the blue center. That's the one place that satisfies all 3 conditions. There's your homework. Bye-bye, butterfly.